Welcome back to SquEEEze's Technological Design Competition. And to proceed with our event, we have the fourth team to present, which is composed of Robert B. Miranda Jr., Roderick L. Fetalbero Jr., and John Rimbirth Pangilinan from Wesleyan University, Philippines, Team A, with their coach, Leo M. Ramos.
Okay, and so for our fourth team of presenters, their research is entitled Solar and Wind Powered Agripest Trapeller. And so, to tell us more about this project, here we have Team 4.
Good day. Good day, everyone. We are from Wesleyan University, Philippines, College of Engineering and Computer Technology. I am Robert B. Miranda Jr., and together with my teammates, Mr. Rimbirth Pangilinan and Mr. Roderick Albero, have prepared an audio-video presentation for all of you about our research entitled Project SWAT. So if we may direct our attention to the monitors, let's watch and learn about this interesting innovation. Food security is one of the sustainable development goals that we need to focus on nowadays, according to the United Nations Development Program 2015. However, pest infestation is still one of the main challenges that needs to be addressed in our farmer situation. Pest management systems could significantly affect their capacity to increase their harvest and food production capacity. In the context of the Philippines, diamondback moths are known as one of the most destructive pests of the crops, while the Eurasian tree sparrow is recognized by farmers as a serious pest to their rice fields. Currently, our farmers are utilizing existing technologies regarding pest management systems. Many farmers are putting scarecrows and using frightening sounds like gunshots or firecrackers to scare away the birds and prevent them from feeding on the grains. They are also installing tide cans or plastic bags at the rice fields and spraying chemical insecticides within the area that could pose environmental problems. On the other hand, the potential of renewable energy sources is enormous as they can meet the world's energy demand. Renewable energy sources such as biomass, wind, solar, hydropower, and geothermal can provide sustainable energy service. In the Philippines, the utilization of solar and wind energy is one of the most significant aspects to promote clean and affordable energy for the people. An average of 161.7 watts per square meter of solar radiation can be converted into electricity using a solar energy conversion system, while the energy from the wind with an average wind speed of 4.66 meters per second can be converted using a wind energy conversion system. From all of this, our team proposes Project SWAT, or Solar and Wind Powered Agripest Trapeller. Project SWAT integrates the principle of wind and solar energy conversion systems to the problem of pest management in farms. Using a combination of 300 watt solar panel and 18.2 watt Savonius wind turbine, the system can produce up to 1.94 kilowatt-hour of clean energy per day. This energy will be used to power the control systems, ultrasonic bird repeller, and UV bug zapper to act as the pest management system of the farm. Overall, the system consumes 1.77 kilowatt-hour of energy per day. To further explain the flow and the construction of the system, in this project, the innovators will utilize a 2-inch metal pole to act as the main mounting mechanism where the bug zapper, ultrasonic bird repeller, control panel, battery, solar panel, and wind turbine will be mounted. The pole will be buried 3.5 meters below the ground and will carry the whole system. For the power generation, two 150 watts monocrystalline solar panels mounted 2.7 meters above the ground with an A-shaped frame, and a vertical axis Savonius wind turbine with a height and diameter of 1 meter, mounted 3.7 meters above the ground, will be used as the system's energy sources. The electricity produced by the wind turbine will go to the wind charge controller, which consists of an AC-DC converter and DC voltage regulator. On the other hand, the electricity produced by the solar panel will go to the charge controller. The output of the charge controller will then charge up the 250 Ah deep cycle lithium-ion battery. The stored energy on the battery will be used to power up the system. Using a light sensor, the ultrasonic bird repeller automatically activates during the day, where most of the birds are feeding. It will be mounted 2.5 meters above the ground. The ultrasonic bird repeller is composed of a 555 timing circuit which determines the duration and interval in which the ultrasonic buzzer produces up to 25 kHz ultrasonic sound wave in 4 orthogonal directions. The ultrasonic waves will deter the bird activity within an area of 1 hectare. Using the same light sensor, the UV bug zapper automatically activates during the night where the light trap is most efficient. It will be mounted 1.5 meters above the ground, which is the ideal height for a light-based insect attractor. The bug zapper will utilize 4 40 watts ultraviolet bulbs to attract moths and other insects within an area of 1 hectare. Upon attraction of the moths and insect, the electrocuting cage made up of 2-layer cage with a 2000 volts potential difference that surround the ultraviolet bulb will electrocute and kill the pest. The outer cage of the electrocuting cage will be connected to the ground to ensure the safety of the user, while the inner cage will be connected to the Cockcroft-Fulton generator. And unlike traditional light traps, this system utilizes high voltage to vaporize the pest for minimal cleaning and maintenance. Through this construction and design techniques, the Project SWAT or solar and wind-powered AgriPest trap-peller can be installed on farms that needs a pest management system easily and protect the farm against bird, moth, and other insect infestation within the area of 1 hectare. The result of Project SWAT could have a positive outcome for the agricultural community as it gives more selection to their way of controlling pests in their farmlands. It can also promote sustainability as it utilizes clean and affordable energy. Hence, Project SWAT does not only offer clean and affordable energy, but also a cleaner pest management system. Our team is looking forward to working with you in achieving this project. And together, let's pave the road for a cleaner and prosperous tomorrow. Thank you everyone for watching our audio-video presentation. I hope that you appreciate the importance and future impact of Project SWAT, not only on bringing clean and affordable energy for the people, but also in empowering our farmers and communities. If you have any questions or clarification, we are pleased to further our discussions with you. Again, I am Robert Miranda, and together with Mr. Rimbirth Pangilinan and Mr. Roderick Fetalbero, we would like to thank all of you for your time and attention.
Okay, thank you, Team 4, for that interesting presentation you showed us. And once again, I am surprised with the creativity of our participants. Their project SWAT looks like it came from a movie. What do you think, Ardy?
Yes, I agree, Donna. And definitely, though it is like one of the most interesting projects we've seen, this project SWAT, there's a lot to consider here, especially that it's not only talking about renewable energy, it's also considering environment management through the management of pests in a clean way. And so, with that, I believe that our judges would have a lot of questions for them. So, with that, proceeding to the Q&A portion with our judges. Judges, once again we request you to turn on your camera to commence the start of the Q&A portion.
Okay, if you're ready, judges, you may now start asking your questions for Team 4.
Hi, good morning. I'd like to start this time. Um, I think I appreciate no that this is solving a problem that's uh based on agriculture and replacing all those harmful chemicals. My question is on the design of the tower. It's just that the wind the wind is on top and then the solar one is at the bottom. I was just wondering at the height of the sun, which is like 12 noon, wouldn't the wind be blocking the sunlight meant for the solar panels? I don't know. Is it moving or can it be extended out? Yeah, that's my question.
Thank you, ma'am, for that question. Based on our initial design, the base of the Savonius wind turbine will be transparent. So even if the sun is directly above the solar panel, it will not hinder the solar radiation.
Sorry, that it's transparent.
Yes, ma'am. Yes, ma'am. On our 3D, we made it opaque so that our judges can see it.
Even the generator casing.
The generator casing will be composed of a metal that will be welded to the pole.
Right. So yeah, that was just my concern because you want to maximize the solar harvesting. So there maybe consider maybe placing it outward a little bit. So yeah, thank you guys. Thank you.
Thank you, ma'am.
Okay, this is Cyrus. Iris, are you done with your question?
Yes, yes.
Yeah. Yeah. To the team, kudos to the team. It's a very good idea. Actually, I'm quite excited hearing your presentation. Uh, in terms of for the question, in terms of the cost benefit analysis, have you already considered this?
Yes, sir. Based on our initial budget and costing, the total proposed budget of our project is 34,120 pesos. On the other hand, the current cost of pest management system, specifically for cabbage in the Philippines, is around 4,999 pesos per hectare per cropping. So if we calculate it for 6 cropping season per year, the total cost of pest management system for cabbage is around 29,970 pesos. So overall, we can say that the return of investment of our farmers is around 14 months.
Okay, yeah, that's good that you already did your computation. Um, Not actually a question, but just to praise you guys because it's a good idea that you have the redundancy on the energy source. You have your wind and your solar, but it's a good point that Iris pointed out the blockage of the sun because you have your wind turbine at the top. So you might want to reconsider probably extending
The solar panel.
solar panel
Yes, sir.
to maximize the efficiency of your to maximize its efficiency when getting the sun's light. And also you should consider also the durability of your design because it would be placed in an outside sa palayan to, di ba? Sa palayan mapapalagay.
Yes, sir.
So maraming yung wind, yung dust. So marami kayong you have to consider dun sa design ano.
Yes, sir. As we have discussed on our paper, this project is under the subject of actual project testing, whereas different parameters is still need to be considered upon collection of our actual data, actual testing.
Yeah. So just try to lower as much as possible, try to lower the cost.
Yes,
Because yun nga, nakita nyo na yung cost benefit analysis.
Mm-mm.
So if your aim is actually to improve yung agricultural ng sector ng Philippines, so the lower your cost is and the more effective your design is, better for everyone.
Yes, sir. Currently, our estimated cost is
projected using the price of retail. So, however, if we are going to open it to the market and open it to the Department of Agriculture, we can lower the projected cost because we can source our materials at lower cost.
So if this the project of yours actually gumana siya or magawa niya talaga yung intended function niya to repel yung mga bugs and birds, I'm hoping na magawa talaga to in reality. Yeah.
Yes, sir.
Kudos, thank you.
Thank you po, sir.
Okay, so maybe I can go. I think any effort to reduce the harmful pesticides or chemical in our food is a good idea. I just noticed it's a 34,000 peso investment. And so in a 1 hectare plot, abot ba yung impact nun through 10,000 square meters, or have you done any studies like that?
Yes, sir. Based on previous researchers, based on or according to Nathan Hill, the range of effectiveness of the UV bug zapper or UV attractor is around 40 meters. So we extrapolated the wattage rating needed for our UV bug zapper based on the research of Nathan Hill. Using 60 watts of UV light, the range is 40 meters. So we extrapolated it using inverse square law, and we came up that the 160 watts UV lamp is sufficient to cover 1 hectare or 56.5 meters radius.
Okay, so 50 by 15, di ba? So 25 lang yun, square meters.
56.5 meters po, sir.
Okay, 6 times 6
radius
is
po. So it's a
36
circular.
meters, right? Okay lang. So, okay, I guess. So I guess at least you put some process into the sizing of the UV light. Tapos yung sizing ng speakers mo as well, right? Those speakers can reach, I mean, 1 hectare, 100 square meters by 100 square meters, right? I guess yung parang,
based on the design, the effectiveness of this system is circular, as the propagation of light and also the propagation of sound is spherical. So there are also another research. Can you show, Sir Rimbirth, here? So based on the research, the necessary sound pressure level needed to repel birds is around 101.4 dB of sound. So we use it to calculate the necessary sound pressure level that we need to utilize. So in this project, we are going to utilize buzzer that is above 136.4 dB to ensure that the range is 56.5 meter within an area of 1 hectare.
oh, well then, well done. I think you size things with at least some calculation. Tapos yung 115 decibels, hindi ba maingay yun?
Yes, sir. This project will utilize ultrasonic frequency, which is around 15 to 25 kilohertz, which is inaudible for the human.
Okay. Yeah, I've seen these at airports as well.
Yes, sir.
Gumagana. Thank you.
Thank you, sir.
Judges, do
Sure.
we have further questions?
What's your consideration with regards to weather conditions in the area? Like,
Yes, ma'am.
is it built for typhoons and yeah?
Yes, sir. Yes, ma'am. Actually, we have done a calculation for that also. So during a severe weather condition, whereas the wind speed is around 61.1 meter per second. This wind speed is the equivalent for signal number 4 and signal number 5 typhoon. So the revolution per minute of our wind turbine is around 1,166.92 revolution per minute, which is within the capacity of the bearings and other mechanical support that we are going to use. So yes. However, for the average wind speed here in Nueva Ecija and also on the average of the Philippines, whereas the wind speed is around 4.66 meter per second, the RPM of our wind turbine is around 89 revolution per minute.
Yes, and also considering it's a field, no, it's going to be the highest point in the field.
Yes, ma'am.
How about lightning strikes?
So in this project, we are going to ground the pole so that it can be protected against electric current.
Yeah, thank you.
Thank you, ma'am.
In relation to that, how about earthquake?
As I have discussed earlier, sir, we are going to bury the pole 3.5 meters below the ground. So it will carry the whole system. But again, the actual support system for the system is subjected to the actual project site testing. So if we may observe that we need extra support for the system, we may do so.
Okay, thank you.
Thank you, sir.
Okay. So with that, thank you so much to our judges. And if there are no more questions, that is the end of the Q&A portion. So once again, thank you so much to our judges for their insightful questions, as well as Team 4 for that coherent presentations. And so Donna, do you think what an amazing segment we've had there? No?
Definitely. So well done to Team 4 as they were able to answer each question that was asked to them. So, Team 4, you may now return to your breakout room. And now, as we transition to the next set of presenters, let us wait again for a few minutes.